We generally the treatment is done to remove um, floating particles and big um, particles like branches of tree, leaves, plastics, then pieces of paper, rag, etc. And then uh, that is done, and some grits, the sand is also removed in the preliminary treatment. Once the preliminary treatment is done, the second, this one is primary treatment, the second step. In the primary treatment, whatever the pollutants which are not removed in the preliminary treatment, that is removed. That is the particles which are lighter and which may be settleable. Those are removed in the sedimentation, in the primary treatment. So, to remove those types of suspended and settleable particles, we are going to utilize sedimentation tank. And we have discussed about the sedimentation tank also in the previous session. Sedimentation tank is nothing but a tank which is used to remove the very light particles, the particles whose specific gravity is more than 1. And what we generally do is the wastewater is allowed to keep quiet in the tank for some time. Particles will settle down and take out the supernatant outside, and whatever the particles which are settled, what we call it as primary settling sludge, is taken for the next treatment. So sedimentation tank, if you ask what is sedimentation tank is a very simple tank. It may be categorized into,
ಸರ್
yes, hello,
ಸರ್ ನಿಮ್ಮ ಸ್ಕ್ರೀನ್ ಶೇರ್ ಆಗ್ತಿಲ್ಲ ಸರ್ ಈಗ.
1 minute. Can you see the slides? Hello,
ನೋ ಸರ್.
ಕಾಣಿಸ್ತಾ ಇಲ್ವಾ?
ಇಲ್ಲ ಸರ್.
ಕಾಣಿಸ್ತಾ ಇದೆ.
ಎಸ್ ಸರ್, ನೋ ಇಟ್ ಇಸ್ ವಿಸಿಬಲ್.
Okay. Coming to this design of primary sedimentation tank. Uh, Again, I was talking about the types of sedimentation tank. Types of sedimentation tank may be categorized into horizontal sedimentation tank and um the circular sedimentation tank. In the horizontal sedimentation tank, the the wastewater flow is in the horizontal direction, and whereas in the circular tank, wastewater flow may be a vertical direct from bottom to the top. Uh, the sedimentation tank may also be categorized based on the shape. Some tanks are rectangular in shape, and some are circular in shape. So, generally, rectangular tanks and circular tanks are utilized in the sewage treatment plant. And coming to the in this session, where our main aim is to understand and to design the primary sedimentation tank, design of primary sedimentation tank. Primary sedimentation tanks are designed using average dry weather flow, and it is checked for peak flow conditions. The number of tanks that are determined by limitations of the tank size. Two tanks in parallel are normally used, so that if one if is in trouble, we can go for maintenance, and in the other, we can use it. And coming to the diameter of circular tank may range from 3 to 60 meters. Just keep it in mind. The diameter of the circular tank is from 3 to 60 meter. Generally, around to 45 meter is a typical one, and it is governed by structural requirements because we have to construct a lot of truss works, so that scrapping arrangement, whatever the waste that are settled down, what we call it as sludge, has to be scrapped out and taken out for the next operation. So the size is generally governed by the structural requirements. And as far as rectangular tank is concerned, rectangular tank with length 90 meter are in use, but usually length more than 40 meter is not preferred. Around 40, 50 meter length is fine for the sedimentation tank, because the land availability is also has to be seen. Coming to the depth, if we discuss about the length and the diameter, the depth of mechanical clean tank should be as shallow as possible. It should not be so deeper, with minimum 2.15 meter. The average depth of the tank used in practice is about 3.5 meter. In addition to the depth, whatever the waste that are going to be settled in the sedimentation tank, we have to allow, or we have to give space for that also. So it is 0.25 meter is given, that is sludge zone, and a free board, so that the water should not, the wastewater should not spill out of the tank. So we give a free board of 0.3 to 0.5 meter. So minimum 2.15 to 3, the 3.5 plus 0.25 is the sludge zone, and zero point 0.3 to 0.5 meter is the free board. And as far as the floor is concerned, floor slope has to be provided so that the settled sludge is easily taken out, and it is generally 6 to 16% for circular tank and 2 to 8% for rectangular tank. The surface, another point for designing the sedimentation tank is the surface flow rate. The surface overflow rate is generally assumed to be 40 meter cube per meter square day. It is in the range of 35 to 50 meter cube per meter square day. Is used for design at average flow. See, this is the flow rate for average flow. At peak flow, the surface overflow rate of 80 to 120 meter cube per meter square day could be used uh, to design the primary sedimentation tank. Lower surface settling rates are used when waste activated sludge is also settled in the PST along with the primary solids. In this case, the surface overflow rate of 24 to 32 meter cube per meter square day and 48 to 60 meter cube per meter square day are used for average and peak flow conditions respectively. And another important with this overflow rate, uh, detention time. Detention time is nothing but this is the time for which the wastewater is going to be in the settling tank. The detention time in primary sedimentation tank could be as low as 1 hour to a maximum of 2.5 hours. You can go for 4 hours, 5 hours, but if the detention time increases, understand, the amount of wastewater that is to be treated will definitely come down. So usually we maintain a low detention time. Providing detention time of 1.5 to 2.5 hour at average flow is in common practice. 1.5 in the 2.5 hours or detention time use ಮಾಡ್ತೀವಿ. With these information, let us go for the design of a primary sedimentation tank. We'll design a rectangular tank. The question is design the primary sedimentation tank to treat wastewater with the average flow rate of 10 mld, 10 million liters per day. This is the amount of flow that is coming to the STP, and sometimes the peak flow is 22.5 mld. Here, in solution, I'll start with the assuming the settling rate. Surface settling rate is 40 meters cube per meter square day. This you have seen in the previous slides. Therefore, using this, surface area of the tank required is, as the average flow is 10 mld, 10 into 10 to the power 6 divided by 40, it gives you 40 into 10 to the power 3. It has been converted into liters. Okay, you get 250 meters square of a tank area. That is the tank area that is required for this average flow. So whether this tank surface area, whatever we have got now, will it going to take up the peak flow load? Let us check it. The SOR at peak flow is 22.5 into 10 to the power 3 by 250. So it comes around 90 meter cube, and definitely 80 to 120 meter cube per meter square day is the surface loading rate at peak conditions you have seen in the previous slides. So 90 meter cube, whatever we have got, is well within the limits. So this is good for the peak flow. ಏನು ಮಾಡಿದ್ದೀವಿ ಇಲ್ಲಿ ಅಂದರೆ ಸರ್ಫೇಸ್ ಸೆಟ್ಲಿಂಗ್ ರೇಟ್ನ ಒಂದನ್ನು ಅದರ ಲೋಡಿಂಗ್ ರೇಟ್ನ ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ 40 ಮೀಟರ್ ಕ್ಯೂಬ್ ಪರ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಡೇ. ಅದರಿಂದ ಸರ್ಫೇಸ್ ಏರಿಯಾ ಆಫ್ ದ ಟ್ಯಾಂಕ್ ಎಷ್ಟು ಬೇಕು ಅಂತ ಬಾಟಮ್ ಏರಿಯಾ ಆಫ್ ದ ಟ್ಯಾಂಕ್ ಕಂಡುಹಿಡ್ಕೊಂಡಿದ್ದೀವಿ ನಾವು 250 ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಬಂತು. ಇದು 10 mld ಬಂದ್ಬಿಡ್ತು. ಏನಾದರೂ 22.5 mld ಪೀಕ್ ಫ್ಲೋ ಅಲ್ಲಿ ಅದು ಈ ಲೋಡ್ ಈ ಟ್ಯಾಂಕ್ ಸೈಜ್ ಆಗುತ್ತಾ ಅನ್ನೋದಕ್ಕೆ ನೋಡ್ದು ಸರ್ಫೇಸ್ ಲೋಡಿಂಗ್ ರೇಟ್ ಎಷ್ಟು ಬರುತ್ತೆ ಅಂತ. ಅದು 90 ಮೀಟರ್ ಕ್ಯೂಬ್ ಬರುತ್ತೆ. ಸರ್ಫೇಸ್ ಲೋಡಿಂಗ್ ರೇಟ್ ಸಾಮಾನ್ಯ 80 ಇಂದ 120 ಮಾಡ್ತಾ ಇದೀವಿ. ಹಾಗಾಗಿ ಈ ಲೋಡ್ನ ಅದು ತಗೊಳುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಏನು ಮಾಡೋದು, ವಿಡ್ತ್ನ ಅಸಂಪ್ಷನ್ ಮಾಡೋದು. ಅಸ್ಯೂಮ್ ವಿಡ್ತ್ ಆಫ್ 6 ಮೀಟರ್. therefore what is the length required? area is 250 the ಸಿಕ್ಕಿತ್ತು ನಮಗೆ. ಸೊ ವಿಡ್ತ್ 6 ಅಂದ ತಕ್ಷಣ ಲೆಂತ್ ಎಷ್ಟು ಬಂತು? 41.6 is greater than 40 mm. ಸೊ ಜನರಲಿ 90 mm ವರೆಗೂ ತಗೊಂತಾರೆ. 40 mm ಹತ್ತಿರ ಇದ್ರೆ ಇಟ್ಸ್ ಫೈನ್. So we'll provide 2 tanks, hence provide 2 tanks in parallel. Therefore, total length of each tank is 41.6 divided by 2 plus 2 meter inlet. Suddenly now we cannot take the wastewater directly to a tank. Before that, we have to have an arrangement for inlet arrangement. Otherwise, if you add the water or if you push the wastewater directly to tank, it is going to create the turbulence and particles are not going to settle down. So we'll have an inlet zone wherein we are going to construct baffle vaults, and there the water is fed into the tank. And again, outlet will never take, we won't take the wastewater directly from the sedimentation tanks. We have an outlet zone. So we have to provide an inlet and an outlet zone. So 41.6 divided by 2 gives you plus 2 plus 2, it is around 24.85 meters. See, you have already designed the primary sedimentation tank in the water supply engineering. Even this design is also based on this the same principles. So now at peak flow, the flow through the velocity. What is the flow through the velocity? Because we know we have assumed the depth, the width of the tank as 6 meters, and we have found the area, the floor area based on the assumption of 40 SLR. So what is the peak flow I'm going to get through this tank if I design? It is 22.5 into 10 to the power 3 divided by 2 into 6 into 2.5. And so it is 750 meter per day, that is equal to 0.0087 meter per second. So horizontal velocity should be checked for non-scoring velocity, that is less than 0.06 meter per second. So what is the total depth? Total depth is 2.5 meter plus 0.5 plus 0.25. So that is 3.25. Sorry, we have missed this one. We have to start with the detention time. Actually, once you get the total length of the tank, 24.85 meter, next is we are going to assume the detention time of 1.5 hour. So what is the liquid depth required? Liquid depth required we get is 40 into 1.5. Here the formula is there. The above, using that formula, we know 40 into 1.5 divided by 24, that is 2.5 meter. Therefore, flow through the velocity, ಈ ಡೈಮೆನ್ಷನ್ಗೆ ಡೆಪ್ತ್ಗೆ ಏನು ವೆಲಾಸಿಟಿ ಇದೆ ಈ ಸೈಜ್ಗೆ ಅಂತ ಗೊತ್ತಾದಾಗ 0.0039 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್. ಸೊ ಇಟ್ ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ 1 ಮೀಟರ್. ಜಾಸ್ತಿ ಆದಾಗ ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಕೋರ್ ದ ಮಟೀರಿಯಲ್. ಸೊ ಇದಾದಮೇಲೆ ಪೀಕ್ ಫ್ಲೋಗೆ ಈ ವೆಲಾಸಿಟಿ ಆಗುತ್ತಾ ಅಂತ ನೋಡ್ಕೊತಾ ಇದೀವಿ. ಅಟ್ ಪೀಕ್ ಫ್ಲೋ ದ ಫ್ಲೋ ಥ್ರೂ ದ ವೆಲಾಸಿಟಿ ಈಸ್ 22.5 into 10^3. So 750 meters per day, it is in meters per second. So horizontal velocity should be checked for non-scoring velocity, which is 0.006 meter per second. So fine. So what is the total depth? We got 2.5 meter as the total depth. ನೋಡಿ ಇಲ್ಲಿ ಬಂದಿದೆಯಲ್ಲ 2.5 ಮೀಟರ್ ಅಂತ ಬಂತಲ್ಲ ಇಲ್ಲಿ ಲಿಕ್ವಿಡ್ ಡೆಪ್ತ್ ರಿಕ್ವೈರ್ಡ್. ಸೊ ಅದಕ್ಕೆ 0.5 ಮೀಟರ್ ಫ್ರೀ ಬೋರ್ಡ್ ಸೇರಿಸಿದ್ದೀವಿ, 0.25 ಸ್ಲಡ್ ಝೋನ್ ಸೇರಿಸ್ತು, ಸೊ 3.25 ಆಯಿತು. ಸೊ ಇಲ್ಲಿ ಏನೇನು ನಾವು ಅಸಂಪ್ಷನ್ ಮಾಡಿದ್ದೀವಿ, ಒಂದು SLR ಅಸಂಪ್ಷನ್ ಮಾಡಿಕೊಂಡು, ಇನ್ನೊಂದು ಡಿಟೆನ್ಷನ್ ಟೈಮ್ ಒಂದು ಮೆಜರ್ ಅಸಂಪ್ಷನ್ ಮಾಡಿಕೊಂಡು, ಒಂದು ವಿಡ್ತನ ಅಸಂಪ್ಷನ್ ಮಾಡಿಕೊಂಡು, ಸೊ ಎಲ್ಲ ನಮಗೆ ನೆಸಿಟಿ ಇದೆ ಅಲ್ಲಲ್ಲಿ ರೈಟ್ ಥಿಂಗ್ಸ್ನ ಅಸಂಪ್ಷನ್ ಮಾಡ್ಕೊಬೋದು ಡಿಸೈನ್ಸಲ್ಲಿ. 3.5 ಅಂತ. ಸೊ ಕೊನೆಗೆ ವಿಯರ್ ಲೋಡಿಂಗ್ ರೇಟ್ ಅಂತಿದೆ 10 MLD ಎವ್ರಿ ಡೇ ಇದಾಗ್ತಾ ಇರೋದು. ಸೊ ಡಿವೈಡೆಡ್ ಬೈ 12 ಗಿವ್ಸ್ ಯು 833.33 ಮೀಟರ್ ಕ್ಯೂಬ್ ಪರ್ ಮೀಟರ್ ಡೇ. It's quite naturally greater than 185. So wear loading rate is also fine. So what is the length of the wear required? Length of the wear required is 10 into 10 to the power 3 divided by 185 gives you 54.5. So hence provide about 27.1 meter of wear length for each tank. This can be provided by 2 effluent collection channels across the width at outlet and offering total 24.0 meter and side wear of total 1.55 meter on each side. This is how the tanks are designed. So only thing you have to keep in mind is surface settling rate has to be assumed. Based on that, surface area of the tank is found, and that surface area tank, whatever we have designed based on that SLR, will it cater 22.5? That is calculated. It's well fine. Again, we have assumed the width. Based on the assumption of width, length has been calculated. So total length of the tank has been calculated. Then we have assumed the detention time of 1.5 meter, and using that we have calculated the liquid depth. Liquid depth ಆದಮೇಲೆ ಫ್ಲೋ ಥ್ರೂ ದ ವೆಲಾಸಿಟಿ ಎಷ್ಟು ಬರುತ್ತೆ ನೋಡೋದು, ಲೆಸ್ ದ್ಯಾನ್ 1 ಮೀಟರ್ ಬಂದಿರೋದ್ರಿಂದ ಫೈನ್. ಪೀಕ್ ಫ್ಲೋ ಏನು ಬರುತ್ತೆ ನೋಡೋದು, ಅದು ಕರೆಕ್ಟ್ ಇದೆ. ಸೊ ಟೋಟಲ್ ಡೆಪ್ತ್ ಇಸ್ ಫೈನ್. ಅದರಿಂದ ವಿಯರ್ ಲೋಡಿಂಗ್ ಇದೆಲ್ಲ definitely you go through the textbooks and try to solve more number of problems. This is how the sedimentation tank is designed. You can design the circular tank also. So main assumptions that generally we do is surface loading rate, then width, then the detention time. So these are the things you have to keep in mind while designing the sedimentation tank. Once the water is treated in the sedimentation tank, the effluent from the sedimentation tank is free from very fine particles which have been removed in the sedimentation tank. So if you check the wastewater, which is our effluent of the effluent from the sedimentation tank, definitely it will be low in BOD and COD. The next process is that if it is very well treated, definitely disposal is the next thing that we have to think about. What to do the wastewater which is coming out of the sedimentation tank? Generally it has to be disposed of. If 100 liters of wastewater is taken to a city for our the domestic purposes, around 80 to 90% of the wastewater, 80 to 90 liters of water is converted as wastewater. So it has to be disposed of. So wastewater from the primary sedimentation tank has to be disposed of. Has to be disposed of. Generally, if the organics are present, then it is taken to a secondary secondary treatment, wherein the organics which are present in the dissolved organics I'm talking about, where the dissolved organics which are present in the wastewater will be removed in the secondary treatment before the disposal. If there are no organics, definitely we can throw it to the nearby river. But if organics are present, definitely secondary treatment is to be done. And once the secondary treatment is done, finally, after the secondary treatment, it is taken to a tertiary treatment if tertiary treatment is needed. Otherwise, it is dumped to a nearby river directly without tertiary treatment. So, this is what I wanted to tell you about the session 4, session 3.